Hello, I'm José-Alberto Mesa-Murgado, and I belong to the SINAI research group at the University of Jaén. In this video, I will introduce you to our participation for the Medical Document Profession Recognition workshop under the title of BERT Representations to Identify Professions and Employment Statuses in Health Data. The Medical Documents Profession Recognition, or simply MEDDOPROF workshops, aims to recognize and identify professions or occupations and employment statuses from medical documents written in Spanish. This task is also named as MEDDOPROF NA. Besides this main task, recognizing to whom that mention is aimed to, discriminating between healthcare staff, patient, or its relatives, or simply others, is proposed as a secondary task under the name of MEDDOPROF class. And lastly, the cataloging of these mentions under the European Classification of Competences, or ESCO coding, is proposed as another secondary task named as MEDDOPROF NO. To address these issues, 1,500 medical documents have been provided, which we have split so that 80% of it is used as training data, while the remaining will be our development set with which to run our test. We propose 3 systems, all of them based on BERT representations. First, the Multiclass BETO approach, then the binary BETO approach, and last one, the same binary BETO approach enriched with the ProfNet dataset. So, beginning with the first approach, the Multiclass BETO approach, we have taken BETO, which is a BERT model that has been trained using a huge Spanish corpus, and therefore it is capable of handling all of these workshop tasks by specifying its corresponding labels. We have tested several configurations in order to determine which were the best parameters for each task. The input documents have been transformed into sequence of up to 215 tokens, and we have tested several batch sizes, specifically 8 and 16, and also different epochs that range from 3 to 5. We have done this using the PyTorch framework for Python that enables us to handle machine learning and deep learning algorithms. Now, the second approach, the binary BETO approach, relies on using 2 labels instead of multiple ones, as it happened with the multiclass approach. Therefore, we catalog tokens of a specific sequence, whether they are part of an entity or not. And after that, we use a BETO pre-trained model, and specifically its 4 last layers, in order to extract its related word embeddings. With these word embeddings, what we do is to compare them to the ones that are related to the labels of each task using the same method. And after that, what we do is to compare them using the similarity method, so that we can be able to assign a label to that entity based on the highest similarity against it. Finally, the last approach takes its grounding from the binary approach we have just seen, but enriches the training corpus with 10,000 tweets from the ProfNet dataset in which we also participated. To evaluate the performance of these methods, we used the evaluation script given by the organization, along with the dataset that we have split before. The results plots here are associated to the development set and hold values for precision, recall, and F1 score respectively. As we see, for the MEDDOPROF NER and MEDDOPROF class, we have tested all of our 3 methods, while for the MEDDOPROF NO, we have only used the binary approaches. The data shown here says that the best approach was the binary BETO approach enriched with the ProfNet dataset. Now, this data is instead related to the evaluation dataset provided to rank the words of participant systems. So respect the same order we have just seen before. For MEDDOPROF NA, we submitted all of our 3 systems, and as seen, they are really close to the best results for this task, and between them. Secondly, we also submitted our 3 systems for the MEDDOPROF class, and as it seems, our multiclass approach was really close to the best one, but unfortunately, our binary approaches were distant, not only for the best system, but also from our multiclass approach. Now, finally, for the MEDDOPROF NO task, we only submitted our binary approach, and as it can be seen, they are not only very similar between them, but also close to the best one. We decided to check what entities we had correctly labeled, which weren't correctly labeled, and what entities were the ones that we have missed. So we concluded that for the multiclass beta approach, there were some mentions of entities for which we have identified more tokens than what was expected, as we highlight in here. So for example, for the word, well, for the entity compañera, we identified it as compañera de la peluquería. And sometimes it happens the other way around. That means that if the entity was composed of more than one token, and we actually only identify one of it, one or two of them. So also for the binary approach, what we observe is that most of our errors correspond to the MEDDOPROF class task, the second task, and they were basically due to battle labeling. What we noticed is that even though they were correctly identified as mentioned, as mentions of an entity, they belong to another label. For example, the sample we have given is the entity psicóloga, which was identified by a model as otros, while instead it should be sanitario. We believe that in both cases, this may be resolved by getting more samples of these entities, so that we have more, so that the embeddings closest to the respective class, and so that there aren't bad labeling errors. And finally, for the MEDDOPROF no, what we notice is an error on our label assignment code. As for certain mentions of entities, we catalog them incorrectly. That is, that the code lacked the term STID, and well, I will explain now how we solve that. So to fix this error, we decided to aggregate the term STID to those codes that lack it, and then we ran an experiment with the same data that was submitted using the evaluation script that we mentioned before. This led to a significant increase in both the precision, recall, and consequently F1 score, as it can be seen in these tables. To conclude, the multi-class approach has obtained the best results on the first and second task, while for the last one, MEDDOPROF no, the binary approach is enriched with the ProfNet dataset has been the one that seems to perform best at this task. So what we see is that actually the ProfNet dataset has helped to improve the performance of our systems. Also, that the binary approaches seems to have problems handling some entities because, as I mentioned before, we probably need more samples of certain mentions of certain entities, as this can cause bad labeling of some entities. Basically, because we are using word embeddings and we are comparing to which label they are supposed to be closest to. As a future work, what we want to do is to implement bidirectional long short-term memory recurrent neural network, BLST neural network, to check whether it would handle these tasks better than our beta models. And we also want to adjust the multi-class beta approach so it can also handle the last one of the workshop tasks, the MEDDOPROF no task, and check whether it will outperform the binary approaches or not. This concludes our presentation. I will now answer your questions, and that's it. Thank you very much for your attention.